Just want to show you how well it sticks together. This is just done with special material tape, but I have that. But the one problem with these cells is that they're pretty fragile. So I just want to do this. And hopefully with the newer ones from Germany, that'll go a lot, they'll be a lot less brittle. But we can continue. And just simply grab this little piece of wire that we'll be able to provide. Now this is the tape that we're using. It's called Kapton tape. It has a high resilience to heat and sun and ultraviolet radiation. We'll use little elementary school scissors to cut that stuff. We'll give everyone a big spool of it. You simply just have to put it on, swipe it down. I like to push it down a little bit more. And you flip it over. You realize that you're a little bit too long. You cut it again with those elementary size scissors. Pull it off. Just fold her over. The trick is to just have contact within one spot and not press these too hard because they're pretty fragile. I'm just going to be picky and have them all lined up like that. 1, 2, 3, 4, 5, 6. But then what happens is each cell gets flipped upside down and you put a taped crosshatch. And the one thing that you want to ensure is that when you're playing around with these, you only touch them on one side, because this is like a little teeter-totter. And if you press it on both sides, you're trying to flex your teeter-totter in an angle that it doesn't want to go. I'm just going to put the tape on, line it up, You can walk it back and forth, but because that wire's on the other side, you have a little bit of a pivot, so you can touch on both sides and it stretches. But if you touch pretty hard right in the centers right there, it will break. So we'll probably give people cotton swabs to be able to push around with it. So you have a limited amount of pressure, but it still looks pretty good. And I'll do another one. And again, this tape is pretty sticky, so we'll have to figure out a way to disperse it out to the people easily without having one person running around constantly cutting pieces and giving up more. But we'll have lots of spools of it, so we should be good. Ooh, are you gonna go out?
It is wind.
So we have one string. And let's come in with our tape and apply another. And you can see that these strings look beautiful, but this is the positive lead of these sides, because these lines, this blue face is the negative side and the back of the cells is the positive side. But what we're going to do is test and compare the voltage output of each array to each other. It's 1.49 volts. 1.37 volts, so that means that we're about in the same run. Because honestly, if we're to mess up one, you would see a drop in that, but messing up two is not really, doesn't really occur too much. So here's the frame for the solar panel, and you can see how it just barely fits. And that was per the design. Boy, is that a close fit. But it looks good, and I think I'll be happy with that. Be very happy. But so then we can increase the voltage of this whole system. We have to swing this around. As when you look at it, it goes minus, plus, minus, plus. So this side is minus and this is plus. So this has to go to a minus. That'll go in there. So that'll go in there. And you can see that's on the top, that's on the bottom. But alright, so this is the one step that I don't exactly know how to get over without doing soldering. But this is a soldering iron, and it's originally been used to do all these connections in the other workshops where we had it more adult based. But as we seek to go towards elementary and middle school students, I had to phase it out. Even though it's a great process, it's hot and not too safe. So this is the one step we need to figure out within the next few weeks. Now we'll just rub the solar panel on it. Just dribbling it in the very center so it has a chance to There's a few techniques of flooding this cell with encapsulant. We're just doing the center method, but there is a waterfall method that we might try as well. but it's a little bit less, it takes a little bit more time. So we'll have to figure that out for the students and what we think would be best for them, as per time constraints and everything. I have pushed down all the cells, and what I like to focus on is pushing it and then bending just a stick right there, so that you aren't directly pushing on the cell, and because our bodies push a lot of force, and you don't want these to break when it's inside this encapsulant. And now what I want to show you is the underside of the cell, and that's usually where you do your final critique. Alright, so we were just able to take her out of the oven, and you can see we have a nice rigid finish to this whole solar panel frame. The encapsulant, what happened is it's a 2-part 10-to-1 ratio encapsulant, and it's slightly textured, so you can feel a little bit of the rubber. The only thing I'm worried about that is that the kids might pick at it over the years and slowly wear it down, but what we can easily do is just pour a little bit more encapsulant into the cracks if a problem ever comes up, and we can fix it quite easily because this stuff bonds to itself really, really well, and it'll bond to the perimeter of the solar panel frame that we're going to have at Traverse City. And so you can see that this is a nice, there's a little bit of hair and a little bit of stuff, nice clean finish, there's no bumped up edges. And one thing that we probably will see at the school workshop is a few little bump ups. And so what happens is, as these solar cells don't lie perfectly flat, and especially as we're trying to make 20 solar panels, I'm not going to have the attention to detail for every single one. So usually what I do right before I put it into the oven is I get that little wooden Q-tip and I push them down, so then they slowly rise up, but before the time that they have to rise up, the encapsulant cures. But that's not a problem. There's literally no hazard about it. If we have like a cell sticking out, we can put some encapsulant over that and it'll be just perfectly fine. The output of these cells is just bare right now. What we're hoping to do is create a little tabbing network so that the students can come in and clip leads to it and measure the voltage or apply that to the K'NEX kits that we have. And I just wanted to show you the nice, pretty final product. One issue that I did have was when I took it all out of the oven, some of this metal spread out, so I did have to press against each of these little contacts because it's just held together with adhesive. So we were able to get away with the soldering, but it worked out really well, and I'm happy with it. It looks gorgeous on the front. The yellow I really like, and I wanted to show you, this is going to be the frame that we're going to have at Traverse City. And it's just a simple little wooden guy because I'm not able to upfront the cost of injection molding quite yet. But we have this wooden frame, and it works and looks great. We're going to have a little bit of extra space just because I know that some people might make them a little bit cockeyed or they'll be stretched a little bit wider. So this will be our working envelope for the whole solar panel. Oops, sorry. They're kind of perched precariously right there. So this will be the whole working envelope that the students will be able to have. And it's not, it's perfectly, it's pretty close. And so it's quite a bit bigger, and which makes it more expensive than encapsulant, but it'll give us a lot of room to wiggle as the kids and families make their panels. And so this will give us a nice rigid, so if they slap it down or hit it, the wood will absorb some of the shock, and we'll be able to have a nice ledge to add silicone there to hold down the glass initially, which is one issue that I have right here, where the glass isn't held too hard on. So this will be a really great option. So with that, I just wanted to say thank you for this opportunity, and can't wait for 2 weeks to happen, and we can make these solar panels for the kids. All right, goodbye.